I'm going to go through the answers to the 2018 preliminary mid-course examination. So this is the Year 11 half-yearly. It was a 50-mark test. It was only 90 minutes. And I'll try and go through it as quickly as I can, but still covering all the main points. So the first question is, which is the following is a second-order lever? The answer to that is it's a wheelbarrow. And if we have a look at our three orders of levers, a first order lever is something like scissors or a wheelbarrow or even a hammer. Second order lever is a seesaw, a hammer or pliers. Second order lever is a wheelbarrow or a nutcracker. And a third order lever, I always talk about a fishing rod, but even tongs or tweezers are third order levers. It has to do with the location of the fulcrum. So if the load and effort are opposite of each other from the fulcrum, then it's first order. If the load is near the fulcrum, it's second order. And if the load is far from the fulcrum, it's a third order. Third orders, they don't have a positive mechanical advantage, or they have a mechanical advantage, more correctly, they have a mechanical advantage less than 1. We will talk more about that later. Okay, so we're going to go through. Now the next one is, what is the velocity ratio of this pulley? Now we've talked about velocity ratio, but in the Eureka videos they call it mechanical advantage. Velocity ratio is perfect mechanical advantage. That's assuming 100% efficiency. So in this case, if we had perfect efficiency, our mechanical advantage would be 4, but the other way of referring to that is a velocity ratio. We can tell it's 4 because there's 1, 2, 3, 4. There's 4 strings connected to moving pulleys. We don't worry about the top pulleys, we only look at the moving pulleys. 1, 2, 3, 4. So we get a mechanical advantage of 4. Okay, so just to give you some other examples, Wikipedia has some other examples. This one, for instance, here would have a mechanical advantage of 3. 1, 2, 3. Okay, so the next one is bronze. Now, using the rule of 1Z, bronze can't be zinc because that'd be 2 Zs. Bronze is copper and tin. If I'd set it up earlier, I would show my picture of the Tin Man, who's old, and bronze, like the Olympics, is old, whereas cricket is new, so they wear zinc. So I say bronze is made from tin, which is old. Brass is new. Think of brass instruments; they're new instruments, not like an old an old horn. And so whenever I talk about it, I always say that brass is made of copper and zinc. For what it's worth, I was going to have a question about interstitial alloys and substitutional alloys. That bronze and brass are both substitutional alloys. Okay, what is the term for a non-crystalline solid? Well, the answer there is amorphous. So amorphous means it doesn't have a crystal structure. It's a solid that doesn't have a crystal structure. The example we typically give is glass, but many polymers are also amorphous. Polymorphous below means that it can have multiple forms, that it can have multiple crystal structures. So steel is an example of something that can have multiple crystal structures. Carbon can have multiple crystal structures. Okay. The next one is, which method is most commonly used to weld stainless steel and aluminium? So to weld stainless, we can use other forms of welding, but TIG welding is the one that's most commonly used. It's the best answer for stainless steel and aluminium. So we've talked several times about, I can close this one and this one. Welding, I put a fair bit of stuff on the internet, on our group chat for welding. So TIG is most commonly used for aluminium and stainless steel. The next question, which leads straight into, is which one's most commonly used on site? Stick welding is much harder than MIG welding, but the advantage of stick welding is that it can be done on site. It doesn't need factory conditions. MIG needs, because of the inert gas, it really needs factory conditions, because otherwise the inert gas can be blown away and we get imperfections in the weld. Okay. The 4 stages of the combustion cycle. Again, we've talked a little bit about this. I think I gave plenty of prep to say that although this isn't explicitly in the textbook, it's not explicitly in the syllabus either, it's an important development in the history of engineering, so it's something we like to talk about. So the 4 steps are intake, compression, combustion, exhaust, which a lot of people remember as suck, squeeze, bang, blow. All the power, a question that sometimes comes up is that all the power is generated from the combustion stroke. The rest of it is sort of set up and clean up. Okay, next question is identify where refractory materials are required. Refractory materials are used in hot areas. So the main ones I always talk about is when I worked for a limestone mine and the 2 German engineers who were refitting the mine, that they told me in quite serious tones about the reason they use clay bricks to line the kiln is to deal with the hot temperatures. Also, I talk about the space shuttle and how I believe it's the Challenger, the Columbia, which I believe that blew up because the tiles on the outside were damaged and led to the melting or the reduced structural properties of the interior of the shuttle. Okay. Which of the following describes metallic bonds? Positive ions surrounded by electrons is the correct answer there. Whereas B is for covalent and C is ionic. Okay, don't be fooled that just because something says all of the above, that it is in fact all of the above. Okay, so we have common crystal structures that we talk about. There's a few common crystal structures, but we really like to try and keep it fairly simple. We talk about BCC, body-centered cubics, body face cubics, and we can see the difference of the arrangements of these of the atoms or the ions in the case of metals, how they arrange themselves. There are others that we need to know about. HCP is hexagonal close packed, and we often talk about BCT, body-centered tetragonal, but we haven't talked about them in great detail, and we'll be talking about them more later. Okay, 11. Which of the following is not a discipline recognised by Engineers Australia? So these are the colleges of Engineers Australia. We have structural down the bottom, and then we have this one here is biomedical, not biological. That was the best I could come up with to really test your knowledge of the Engineers Australia disciplines. Okay, the role of the structural engineer. Now, when I was marking this question, I'd forgotten that I'd written it, and that I really wasn't looking for the not, especially seeing as the one above was in dark text. But when I looked at it and thought, well, okay, I would say the best answer, and the one I started correcting and had to go back and change, is that I would have said that the most correct answer is that they need to meet the needs of stakeholders. I would say that sums up all of everything. But seeing as the answer is to what are they not supposed to do, they're definitely not supposed to design the strongest possible structures. That is not their job, right? If they built the strongest possible structures, they'd be way too expensive. They make structures that are just strong enough to not fall down, just strong enough to meet the standard. Because even 2% more than that is enough for your clients to come in and say, why are you ripping me off? Why are you charging me? Why am I paying more for materials than I need to be paying? I'm going to go to someone else who will design this with using less material. Okay. Which of the following is a copolymer? Well, the correct answer is ABS. So ABS is made up of these 3 different polymers. They join together to make 3 different polymers. The other ones, like PVC, looks like it might be a copolymer, but it's actually not. If I look at PVC monomer, we can see that a PVC monomer is actually only one monomer. Okay, which is true of brazing. Brazing uses the same torch as the oxyacetylene containers for oxyacetylene welding, but it usually works at a lower temperature. It is possible to braze without having both containers. You can use smaller handheld containers, but typically it's done using the 2 containers. It's not stronger. It doesn't really distort the shape. It can be used to join different metals, and it requires a lower temperature than welding but higher than soldering. So D is not correct either. So the correct answer is C. Okay, Newton's first law. Newton's first law is that objects tend to do what they're already doing. Objects at rest remain at rest, objects in motion remain at motion until they're acted upon by another force. The other answers may have actually been valuable for people further down the line, but that's up to them. Okay, identify the ferrous metal with the lowest carbon content. So if we go to our ferrous metals here, and so we can see that ferrous metals, we consider steel to be between 1 and 1.5% steel. I'd say cast iron is usually above 2%, and less than 0.1% carbon we consider to be pure iron, or which includes wrought iron. So wrought iron is an iron alloy with a very low carbon content, commercially known as pure iron. Okay. Identify the process used to produce bricks. Now this was in our ceramics handout, and it says clay products. They've been used for thousands of years. They can be extruded, for example, in bricks, or they can be slip cast, like porcelain. So your bathroom basins and toilets. Okay, so that's where we talked about that. Now, matching up this drawing. Well, these things seem fairly obvious to me because I've been doing this a lot. But really what I'm looking for is that this shape here I can see kind of looks like that shape there. And really it's just about matching up these things. I tried to pick one that was as close to being difficult as I could come up with. Our next question is the vector components. So whenever we have 45 degrees, we've talked about that the ratio that's sine 45 or cos 45, in both cases, they're 70.7% of whatever the hypotenuse is. So if the hypotenuse is 1,000 kilometers, well, that means that our either of our sides are going to be 70.7% of that. So 707 kilometers north would be our north component. For question 20, find the resultant of a downward force of... I have to change this one as well. I changed this correct. Now I wrote this up on the board because someone had pointed out that this was incorrect and I have to change it. But I did say that this angle is what we need to have, and I've already corrected this. That the resultant in this case is going to be the hypotenuse of these two numbers. So when we take the hypotenuse of these two numbers, we get this number. And when we take the angle, to find this angle theta, it's going to be equal to the opposite over the, so the arctan, or tan, the inverse tan of 500 divided by 800. So 5 over 8, and then type in, or inverse tan of 5 over 8 will give you, I think it's 32 was the correct answer. Okay, that's all I have time to go through at the moment, and I will do some more later.